Everyone, welcome to a new video of Maths of NIOS Senior Secondary course. We are going to deal with sets. In this video, we are going to see Venn diagram, topic number 1.7, then difference of sets 1.8, then complement of sets 1.9, and the properties of these complement of sets. So before starting the video, I would like you to subscribe to the channel, give it a like if you found the video useful, and share it with your friends. Topic is Venn diagram. What is a Venn diagram? As the name suggests, it is a diagram or a pictorial representation of something which was found out by mathematician John Venn. The name Venn came from his name, and it introduced the concept of diagrams to represent the sets. So sets can be represented not only in the form of roster form and set builder form. It can also be expressed in the form of diagrams. Those diagrams are called Venn diagram. So he explained that the universal set is represented by the interior of a rectangle and other sets are represented by interior of circles. So if you see this diagram 1.1, you can see a rectangle right here which represents the universal set, and this circle A and this circle B each represent the sets inside the universal set U. Universal set U is represented here, and it has 5 elements 1, 2, 3, 4, 5, and another set is there A, which has the element 2 and 4. Another set B is there which has the element 1 and 3. So if you check this diagram, it represents the same 2 and 4 inside A and 1 and 3 inside B set, and universal set is there. So other elements are contained here. So the extra element that came is only 5, that is outside of this circle set, is not in these sets but in the universal set. So diagrammatical representation of set is known as a Venn diagram. This is the definition. Let's move on to next topic, that is difference of sets. So difference of sets, as we know what is difference, two sets will be there and we have to find difference of them. Means you have got set A, you have got some elements here, and set B, some elements in B. So if it is A difference B, that means A minus B, representation of difference is through this minus sign, and A minus B states that you have to have elements of A and subtract the elements of B from A. We will see an example and understand better. The same way, if you have B minus A, you will have elements of B and subtract the elements of A from those B. Set having those elements which are in A but not in B. Okay, as I told you, consider the element A. It has some elements, B has some elements. A's element should be there and B's element removed from the A portion if it is A minus B. The vice versa happens for B. Let's see an example here. A has got 1, 2, 3, 4 and 5. If you want to do A minus B, B has 2, 4 and 6. So remove this 2, 4, 6 is not available. So this 2 and 4 will be removed and the resulting set will be 1, 3 and 5. So you can see here, we can say A minus B are the elements X, where X belongs to A, set A, and X doesn't belong to B. So whatever is there in B should not be there as the result. So that is what the general form says, and the vice versa for B minus A. Is the result of the same, excluding this portion. This all, whatever is in this green color is the representation of A minus B. Similarly, if it is B minus A, whatever is in B and A removed from here. So we can show it using a different color. This portion will be the representation of B minus A. It is not disjoint, this is the result, and if it is disjoint, they doesn't have something in common. This would be the result where they doesn't touch each other. Both the sets doesn't touch each other. Next topic is complement of set. That means if you have a set A, we represent it as A complement. That means whatever you have in A should not be there in A complement, but it can be in the universal set. Pictorially, if you say this is set A and this is universal set, element 1, 2, 3 is there in the set A, means other elements except this one will be the result of A complement. Let's see example and understand. Let X denote the universal set and Y and Z are its subset, where X is any member of the family, Y represents male members, and Z represents female member of the family. So if we take this example, X represents all the members, Y represents male members, and Z represents female members. So X minus Y is all members and subtract the male members. That means you will get the female members of the family. If you take X minus Z, it will be the male members because you have subtracted the female members from the universal set. Here X minus Y is said to be complement of Y. We can say X minus Y is complement of Y, which is denoted by Y complement of Y or Y of C. This is the representation for your complement. So X minus Z can be understood as Z complement. These are the ways to represent them. Definition is given here. If U is the universal set and A is its subset, then the complement of A is the set of those elements which are in U but not in A. That means the complement says everything will be there in the universal set but except the elements of the given set. This is the representation of a complement, and if you see a Venn diagram, it will be like this. If you want to find the complement of this set A, it will be everything other than the set A. This portion is included outside of this set. This can be noted. Let's see an example. 1.14. Given that A has element X, where X is even natural number less than or equal to 10. This is the element in set A. Then B has odd natural numbers less than or equal to 10. So find out which are those. If you take A, it will be even natural number. So natural number, even number starts with 2 natural numbers. So 0 is not included. 2, 4, 6, 8 and 10 because equal to 10 is given. Then comes B, odd natural numbers. So starting with 1, then 3, 5, 7, 9. These are the elements in both the sets. Now we have to find A minus B. So A minus B means both are disjoint set, nothing matches. So this will be the answer. Okay, everything from A, nothing from B. Then B minus A, again you will have the output as this set. B is equal to B is equal to A. A minus B equal to B minus A. No, both are not same. One output is A, another output is B. So this is not true, or they are not equal. Next one is example 1.15. Let's check how to do it. Let U be the universal set and A is subset, where U element X, where X belongs to natural number and less than 10. less than equal to 10. Then A is a subset where Y are the elements. Y is a prime number less than 10. So here if you check, A will have the elements as prime numbers, prime number less than 10. So 2, 3, 5, 7 will be the elements in the set. And you will have natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 included, since it is less than equal to 10 given. So 1 to 10 elements are here in universal set. You have to find A complement. This is the set. So everything other than this will be included in the complement. So if you need A complement or you have C, the output will be 1, 2 not included, 3 not included, 4, 5 not included, then 6, 8, 9 and 10. These are the complement of A of C. Then you have to represent this in the Venn diagram form. 2, 3, 5, 7 prime numbers and other elements will be scattered in the universal set. So this is the representation of your Venn diagram. Next are properties of complement of sets. First one is complement law. Complement law says that any set and union of its complement will give you the universal set. So union will take all the elements from both the sets. Okay, and this represent intersection. This is union and this is intersection. These are the two things. This takes everything common from both the sets. This take all the elements and the repeated elements taken once. So complement law states that any element union of its complement will give you the universal set. That is true. We can check it or verify this law. So the law is A union A complement is universal set. So take a universal set like this and any subset of subset with some elements. So here it has all the even numbers and here it has all the natural number till 10. A complement will be everything other than this even number. So odd number will be the output. 1, 3, 5, 7, 9 are included. Then A and A complement. If you combine both of them, you will get the universal set because each element will be included once if it is a repetition, and combination of both the sets will be taken as the result. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, everything is included, which will be the universal set that we have taken. Okay, so this law is verified. This is verified. The other one says the set and its complement intersection will be disjoint. That means nothing will be matching. It is disjoint. Let's check. It has to have common elements. So if we take A and A complement, nothing will be common. So it gives a disjoint result. The set doesn't have any common elements. So this is also verified. Next one is De Morgan's law. That is a very important law. Very important. So it states when A union B, set A and set B taken union and then done complement, it gives a similar result when you take the complement of both of the sets individually and find their intersection. You can see the difference. It is union, it is intersection, not the same. Okay. Then another law states that if both the intersections are taken and its complement is done, let's check the De Morgan's law. First one is union. So we are taking elements from 1 to 9 in the union set. Then A has element 2, 4, 6, 8 even numbers, and B has 2, 3, 5 and 7 prime numbers. Okay, so these are the two sets. So on the left hand side we are going to find A union B whole complement. So first we have to find A union B. So A union B will give you everything from A set, and B set will be taken repetition recorded ones. So 2 is there, then 3, 4, 5, 6, 7 and 8. This is the set A union B. Now find out A union B's complement. That means everything which is not here will be taken from the universal set. So universal set has 1 to 9. Remove 2, 3, 4, 5, 6, 7 and 8. So the resulting set will be only 1 and 9. Okay, this we got from our left hand side. Now right hand side says A intersection B or A complements intersection with B complement will be the similar result. So let's check that too. A complement once taken will be 2, 4, 6, 8 should be removed, and 1, 3, 5, 7 is the result of A complement. If taken B complement will be 1, 4, then 6, 8 and 9. Okay, these are the two things. Find out their intersection. That means what is common in both of them. So if you see 1 is common, 3, 5, 7, nothing is common other than 9. So 1 and 9. So if you take this left hand side and right hand side, both gives you the same result. So this De Morgan's law, one law is verified. The next law says, the second De Morgan's law, that is this one, A union B complement. So A left hand side, A union B complement, the result is 1 and 9. And right hand side is A complement intersection B complement. So A complement when found separately was this one, and B complement was this one, and you have to find out their intersection. So if you find intersection, again you are getting the same thing, 1 and 9. So the second law is also. So our next intention is to find out left hand side of this De Morgan's law, second one, A intersection B complement. So find out A intersection B. If you see the sets A and B, the intersection of A and B will give you 2 as the result. Okay, and complement of that will be everything except the 2. So this will be the result. Everything in the set except 2. 2 is not here. So this is A intersection B complement. Okay, next you have to find out on the right hand side. If you see here, A complement and B complement you have to find, and then their union. So already we have done here, A complement is available, B complement is available. Find out their union. To find their union, it will be 1, 3, 4, 5, 6, 7, 8 and 9 except 2. So 2 is also not there in the resulting set of A in complement B complements union. So everything 1, 3, 4, 5, 6, 7, 8 and 9. So everything is included except the 2. So left hand side and right hand side gives you the same result. So the second De Morgan's law also verified. It may look a bit confusing because of the numbers and all the laws shown here, but just take the left hand side, solve one by one and then reach the right hand side, or separately solve both left hand side and right hand side and find out the equality between both of them. That will make the problem easier. Next law is double complement. That is a complement of again complement will give you a. So this can be done easily. So if you take this a, again if you take the same set, you have set of all the numbers from 1 to 10, and here you have only even numbers. So complement of a will give you the odd number. Again doing the complement of the odd number will give you the even number. So that can be easily verified, this one. Then comes the law of empty set and universal set. So nothing or the disjoint set complement will be always universal set, and universal sets complement will be disjoint set. This also can be verified easily. Take any values and solve it. If you have got doubt, do comment in the comment section. Hope you understood these laws. They are very important. If you found the video useful, please don't forget to like the video, give it a thumbs up, and share it with your friends, and do subscribe to the channel to get the videos as soon as it is posted. See you in the next video.